Lesson 25 of Precalculus. This is right triangle trigonometry. We're going to evaluate trigonomic functions of acute angles and use a calculator to evaluate trigonomic functions, use fundamental trigonomic identities, and use trigonomic functions to model and solve real-life problems. All right, so right triangle definitions down here. Hopefully you've seen these before in geometry and probably in algebra 2, but just a reminder, you only use sine, cosine, and tangent on a right triangle. It has to be a right triangle to use trig. And it's going to be an acute angle. You're not going to do the sine and cosine of a right angle. So down here we've got a picture of a right triangle, and we're going to call this angle theta. So if that's angle theta and this is a right triangle, the two sides that make the right angle, those are called the legs. The side that does not make the right angle, that's across from it, is called the hypotenuse. So if you're looking at angle theta, this leg is across from it or opposite from it, and this leg here is adjacent to it because it forms the angle. Since it forms the angle, it's adjacent to it. So this is the adjacent leg. So sine, cosine, and tangent, sine's opposite over hypotenuse, cosine is the opposite leg over the hypotenuse, and then tangent is the opposite leg over the adjacent leg. Down here again, opposite, OPP, stands for the length of the opposite angle, opposite of theta, and adjacent is the length of the side adjacent to theta, and then the hypotenuse is the length of the hypotenuse. And you've probably heard before SOHCAHTOA. It's a way to help you memorize sine, cosine, and tangent. Sine is the opposite leg over the hypotenuse. Cosine is equal to the adjacent leg over the hypotenuse. And then tangent is equal to the opposite leg over the adjacent leg. And again, we have those inverse functions, cosecant for sine, secant for cotangent, secant for cosine, and then cotangent for tangent. And again, you need to know all of these. You're supposed to have them all memorized. Know them, love them. On the next page, again, we have a reminder here of our reciprocal functions. Cosecant is sine, 1 over cosecant. Cosine is 1 over secant. Tangent is 1 over cotangent. Cosecant is 1 over sine. Secant, 1 over cosine. Cotangent, 1 over tangent. And then I talked about this on the unit circle. Tangent is equal to sine over cosine, and then cotangent is the flip of that. It'd be cosine over sine since it's a reciprocal function from it. And then these are new today. The Pythagorean identities, sine squared plus cosine squared is equal to 1. If you know this fundamental one, you can generate the next two. So if you know that sine squared plus cosine squared is equal to 1. If you take and divide everything by sine, sine divided by sine is 1, and then cosine divided by sine is cotangent, and then 1 over sine is cosecant. So that gives you the one right here. 1 plus cotangent is equal to cosecant squared. And then likewise, if we take this whole original function, sine squared theta plus cosine squared theta equal to 1, and instead of dividing across by sine, if we divide everything by cosine theta squared, so sine divided by cosine is tangent, and then that's 1, cosine divided by cosine is 1, and then 1 divided by cosine squared is secant squared. So that gives you the identity right here. 1 plus tangent squared is equal to secant squared. So again, if you just know the first one, you can generate the other two pretty quickly. All right, next up, we are going to evaluate trigonomic functions. Find the exact, the key word here is exact. We want to know the exact 6 trigonomic functions given that two sides of a triangle are 12 and 18. Okay, so this is the angle. The angle right here is theta. Again, this is the right angle, so this is a leg. This is a leg. because those are the two sides that form the right angle, the two sides that make the right angular legs. The side across from it's the hypotenuse. And again, the side that makes the angle theta, this angle right here, this side makes it. So this is adjacent to it. And this leg does not make that angle, so it's opposite from it. It's across from it. Okay, so let's do the 6 trig functions. We got cosine, sine, tangent, and then the inverse of cosine is secant, inverse of sine is cosecant, inverse of tangent is cotangent. Okay, remember cosine is the adjacent leg over the hypotenuse. The adjacent leg is 12. Oh, look at that. We don't have a number for the hypotenuse, so we're going to have to find it. Again, it's a right triangle, so we can use trig on it here, the Pythagorean theorem, to find the missing side. So we'll call this side C. A squared plus B squared is equal to C squared. So we're going to do the Pythagorean theorem here real quick. 12 squared plus 18 squared is equal to that hypotenuse squared. So if you do 12 squared plus 18 squared, you're going to get 468. And then C then would be equal to the square root of 468. And when you simplify it, that simplifies into 6 radical 13. If you want help with that, you can ask me in class tomorrow. I'll help you with it. So 6 radical 13 is the hypotenuse. So 6 over radical 13. We're going to leave it like that for now. And then sine is, again, the opposite over the hypotenuse. The opposite leg was 18. The hypotenuse was 6 radical 13. And then tangent is opposite over adjacent. The opposite leg is 18. The adjacent leg is 12. And then the inverses are the flip of these. So just flip it over. So 6 radical 13 over 12. 6 radical 13 over 18, and then 12 over 18. And then we can clean all of them up. Divide these both by 6, and you get 3 over 2. Or this one, again, divide by 6, and that would be 2/3, or the flip of 3 over 2, 2/3. Okay, over here, we've got a couple things going on we should clean up. So 12 over 6, 12, ignoring the radical, you can clean those numbers up. 6 goes in the 12 2 times, so 2 radical 13. And again, we don't want a radical in the denominator, so I'm going to multiply the top and bottom by radical 13. So that gives you, for the final answer on it, 2 radical 13 over 13. Same thing here. We're going to divide 6 into 18. So that makes 3 over radical 13. And again, we don't want a radical in the denominator, so let's rationalize it. So that gives you, for the final answer on that one, 3 radical 13 over 13. Again, this one was 3 over 2. This one just needs reduced to a half. 6 goes in the 12 2 times, so radical 13 over 2. And again, divide that into 3 times. So radical 13 over 3, and again, that one was 2/3. Okay, on the next page, we're going to evaluate trigonometric functions in exercise 11 and 12. They want us to find the exact values of the 6 trigonometric functions for the angle theta for each of the triangles, for each triangle. All right, so on this one, we're given that the cosine is equal to 3/7. What we have to do is make ourselves a triangle. So make yourself a right triangle. Again, trig is all about the right triangle. So there it is. You got to pick an angle to call theta. You could call it this one or that one. It doesn't matter. Pick an angle. So I'm going to call this one theta. And so again, cosine is the adjacent over the hypotenuse. So looking at this side's the hypotenuse, of course, because it's across from the right angle. This is a leg, because they make the right angle. This leg is adjacent to the angle. This leg is across from it, so it's opposite from it. So then filling in the numbers here, the adjacent side's 3, and the hypotenuse is 7. And again, like before, we're going to need to find the third missing side by using trig. So I'm just going to call it x this time. So we have 3 squared plus x squared, because remember, you square the legs, add them together, and that equals hypotenuse squared, or 7 squared. Leg squared plus leg squared equals hypotenuse squared. I'm going to write that. Leg squared plus the leg squared is equal to the hypotenuse squared on a right triangle, or a squared plus b squared equals c squared. But then you have to remember what a and b are, which some people forget. So that gives you x squared then is equal to 7 squared minus 3 squared. Moving that to the other side, so you get 40. And so x equals the square root of 40, which is 2 radical 10. So this side is 2 radical 10. All right, now we can proceed. And they want us to do what we did before, find all 6 of them. So again, we've got cosine, sine, tangent, and then the reciprocal of cosine, secant, cosecant, cotangent. All right, they gave us cosine. Cosine's 3/7. So that's 3/7. And we got the secant, flip it over, that's 7/3. And then sine is the opposite, which was 2 radical 10 over the hypotenuse 7. Flip it over. So you got 7 over 2 radical 10 for the cosecant. And again, rationalize it. So I'm going to multiply by radical 10. So it makes 7 radical 10 over 20. All right, and then the tangent is the opposite. Opposite over adjacent. Opposite is 2 radical 10. The adjacent leg is 3, so all done there. Flip it over for the cotangent, so it's 3 over 2 radical 10. And again, I'm going to rationalize it, so multiply the top and the bottom by radical 10. So it gives you 3 radical 10 over 20. All right, on the next one, we're going to use trigonometric identities to find some of them. And one of the identities that we can use that we didn't cover in the lesson are the cofunctions of complementary angles are equal identities. Cosine and sine, if you look at the wave on it that we looked at yesterday, let me find it. If we look at that wave from yesterday, here it is. If we look at that wave from yesterday, you can see that the cosine wave here and the sine wave are off by 90 degrees. If you just float it over 90, the one lands on top of the other one. And so that's what they mean by their cofunctions. They're just 90 degrees off from being the exact same function. So all you have to do is do 90 minus the angle, and you get the cosine of the other angle. So sine and cosine, secant and cosecant, they're cofunctions. And tangent and cotangent, likewise, their graphs are also off by 90 degrees. So we're going to use that on this. All right, let's start with some easy ones here. They gave us sine. Sine and cosecant are reciprocals. So this is just equal to 1 over the sine of 30. Or flip it over, so I'd make it 2 over 1, or just 2. And then cotangent and tangent are reciprocal functions, so let's knock that one out. So that's equal to 1 divided by a tangent, or flip it over. So instead of radical 3 over 3, it's 3 over radical 3. And again, to make it pretty, multiply by that radical, so it gives us 3 radical 3 over 3, and look at that, it cancels out, and the whole answer is just radical 3. All right, then to do the cotangent one here, what we're going to do, and notice it's 60 degrees, we don't have a 60, but that's where these cofunctions are going to come in handy. It's equal to the tangent of 90 minus theta, and here theta is 60 degrees. So it's equal to the tangent of 30, and we know the tangent of 30, it was radical 3 over 3. So we're all done with that one, using the cofunction of a complementary angle. Again, complementary means 90 degrees, two angles that add up to 90 degrees. That's what complementary angles are. Okay, the last one there, the cosine of 30. There's several ways you can do this. It's other ways you could do all of them, honestly. I'm going to do this one by using the one identity that cosine squared plus sine squared is equal to 1. I'm going to use that one because honestly, it comes in handy overall for anything. So we know the sine of 30 was a half, so that's equal to 1/2 squared, and 1/2 squared is a fourth. A half times a half is a fourth, so that's 1 minus a fourth. So the cosine squared of theta is equal to 3/4. So just the cosine of it is equal to the square root of that, which is radical 3 over 2. You're going to split it. That's radical 3 over radical 4, and the square root of 4 is 2. So this answer is radical 3 over 2. All right, and then on the next page, we're going to use some trigonometric identities. Use trigonometric identities to transform one side of the equation into the other. The key on this, when you do these, is that you want to make the messy side look like the simple side. So we have two sides here, the left and the right. Obviously, this one is simpler. This one's messy. Let's clean up the messy side. We want to clean up the messy side to look like the pretty side. So hopefully it pops out at you that we're going to do foiling on it. So cosecant times cosecant is cosecant squared theta. And then on the outside we got minus cosecant theta times cotangent theta. And then doing the inside we have cotangent times cosecant, so plus cotangent times cosecant. And then last of all, cotangent times cotangent, and it was a minus and a plus, so it makes it minus cotangent squared. All that's equal to, on the other side, 1. So I FOILed this side out. Cosecant times cosecant, cosecant squared, etc. Notice that's plus, that's minus, bam, gone. And so then we're left with cosecant squared plus, oh, well, not plus, minus. Oh, so sad. Cosecant squared theta minus cotangent squared theta is equal to 1. So, I know that'll haunt some of you at home. We'll just take care of it. All gone. Okay, so what we're going to do on that is going back to that other page. We had a trig identity that 1 plus cotangent squared theta is equal to cosecant squared theta. We've got it pretty close here. All we have to do is move that cotangent over. So that would give us 1 equals cosecant squared theta minus cotangent squared. I moved that plus cotangent the other squared side, so it made it minus. So that is equal to 1. And we're all done. 1 equals 1. All right, on the next one. Whenever you see a fraction like this, overall, usually it works to split it. So I'm going to split it. So tangent theta over tangent theta plus cotangent theta over the tangent of theta is equal to cosecant squared theta. Hopefully this looks messier to you. That's the messy side. This is the more simple side. So we want to make this look like that. So when we split it, tangent divided by tangent is 1. And then I'm going to split that up some more. So we got cotangent theta times 1 over tangent theta equals cosecant squared theta. All right, so 1 over tangent, that's a reciprocal function. 1 over tangent is actually cotangent. So it's really cotangent theta times cotangent theta. Oh, I did something bad somewhere. Let's see. So that was 1. That was cotangent. And 1 over tangent's cotangent. Oh, I know how I'm going to do it. All right, it's good. So then, I didn't do anything wrong. It's okay. So then we got 1 plus cotangent squared theta. And that brings us back to that identity that we had before, right here. We're going to use that again. 1 plus cotangent squared. Oh, up there. We're going to use that. 1 plus cotangent squared is cosecant squared. So then cosecant squared theta is equal to cosecant squared theta. And we're done. We've made the messy side look like the simple side. These are hard. It's not going to come easy to you. We're going to do a lot more of these in another chapter. This is just kind of like a baby steps into it. So we'll work on these in class. They are hard. I know they are. All right, on the next page, this takes you back to geometry. We want to find some missing sides on this. So the key when you're solving for missing sides with triangle is pick an angle. And then you want to label the sides. I'm going to just go with the angle they gave us, the 60 degrees. Again, you're not using the 90-degree angle. You're using one of the two acute angles. So if I use that 60-degree angle, this side and that side form the angle. This side's the hypotenuse. This side's adjacent to it because it makes the angle, which leaves this side to be the opposite side. So then you want to use trig identities, sine, cosine, tangent, to find the missing sides. So starting with the 60, if we want to find x, we know the hypotenuse is 16, so we're always going to use that for sure. And we want to find x, which is adjacent. So adjacent hypotenuse and hypotenuse, that's cosine. So because cosine, again, just a reminder, cosine is adjacent over hypotenuse. So the cosine of 60 degrees is equal to the adjacent side x over the hypotenuse 16. And this is where it comes in handy to have your unit circle memorized. I don't know if you saw this, but they want exact values, not rounded values. So if you have your unit circle memorized, the first angle, honestly, just memorize the first angle and all the rest fall into place. The first angle, which is 30 degrees, is radical 3 over 2, a half. And then for 60 degrees, just flip that one. So that becomes 1/2 radical 3 over 2. So remember, it goes cosine and then sine. Cosine, sine. So the cosine of 60 degrees is 1/2. So 1/2 equals x over 16. So I'm going to cross multiply. So I get 16 equals 2x. So x is equal to 8. Okay, then we want to find y. So that's a whole nother function. So finding y, that's the opposite side. And let's use the hypotenuse again, which was 16. Opposite hypotenuse, that's sine. So the sine of 60 is equal to the opposite y over the hypotenuse 16. And the sine of 60 up here on my unit circle, the sine of 60 is radical 3 over 2. And then we're going to cross multiply. So that makes 16 radical 3 equals 2y. So divide by the 2 then. So 16 radical 3 divided by 2 equals y. So that makes 8 radical 3. Don't try to divide by the 2 twice. I see some of you, they're thinking, well, you didn't divide by the 3. No, I divided it into 16. You only get to use the number 2 once. And I used it to divide into the 16. All right, and then they made one into a story problem down here. Find the angle of elevation of the zip line. So doing the first one here, they want us to find the angle of elevation. The angle of elevation is where the little man's looking up at. So the guy standing here, he's looking up at it, so this angle is going to be the angle of elevation. These are both, this is a right angle, this is opposite, this is adjacent, so that would be the tangent. So the tangent of that angle theta is equal to the opposite 50 over the adjacent 50, opposite over adjacent, which is 1. And again, if you memorize your unit circle, you'd know that makes that theta is equal to 45 degrees. If you didn't memorize it, you could look at a unit circle to find it, or you can do second tangent or the inverse tangent on your calculator, 45, and it'll give you 1. Let me show you how to do that again real quick. So on the calculator, go second tangent, 45 degrees. Make sure your calculator is in degree mode. Oh, I don't think it is. So mode, yeah, it is in degrees. Let's see, second tan. Oh, I'm doing second tangent of the number 1. No, second tangent of the number 1, because we're going backwards. And that gives me like 45-degree angle. All right, I think we're out of time. The other 2 questions, honestly, are pretty simple. I'll see you in class.